Hello guys, as you are seeing last few days we are making lot of videos on ISC boards, right? छोटा छोटा video for ISC boards, रोज का रात का dose, ठीक है? So I thought something should be there for ICSE students also. Boards are coming very fast, so we have to gear up and we have to do it in small sometimes revision requires small videos. Okay, so we are making those things and let us see if it succeeds, and obviously it will succeed if we all work together. That's what I believe and that's what you guys also believe. So today we will be discussing a very important point जिसमें से 2-3 नंबर तो आ ही जाते हैं. Important point is reactions of concentrated HCl, and we will be discussing the reducing property of it. Which property? Reducing property. Okay, there are certain compounds which are heavily oxidizing agent which generally reacts with HCl, okay, and forms an oxidation reduction reaction occurs there, and some compounds are formed, some gases may be formed, and all those things happen. And during those reactions, remember the property used of concentrated HCl is reducing property. So please remember this thing, which property is used. Now let us go to one reaction, everything will be clear. So let us do this one, MnO2 plus HCl. Okay, first of all, see, MnO2 is a black colored solid. So what is the color of MnO2? Black colored. What is another compound that you have studied is also having black color, that is copper oxide. Okay, remember another copper oxide is also black. Okay, so if somebody asks you how will you differentiate between copper oxide and MnO2, by reacting it with HCl, you can differentiate it. So if you put in concentrated HCl into MnO2, what will happen? You see, this MnO2 is a very good oxidizing agent. Very good oxidizing agent. Okay, so MnO2 is having lot of oxygen. Let us suppose at this moment, let us assume MnO2 is having lot of oxygen. So it is going to give the oxygen to HCl. So that means it is going to oxidize HCl. Now HCl, what does HCl have? HCl has H and Cl. If you want to oxidize this substance, then what can you do with it? Either you add some oxygen or you take out some hydrogen. Okay? So now before adding oxygen, I can easily take out hydrogen. Now why this hydrogen is getting taken away? This hydrogen is getting taken away due to the oxygen donation of MnO2. So oxygen is reacting with this hydrogen part. So oxygen ka valency 2, hydrogen ka valency 1, and it will form H2O. So first thing, first product is H2O. Okay, next Cl is left behind. Cl अकेला तो नहीं रह सकता, Cl cannot remain alone, so it is going to react with another Cl and form Cl2. Okay, and what is remaining with? We are remaining with Mn, and obviously Mn can also react to, Mn will react with this Cl. Okay, Mn will combine with this Cl and form MnCl2. Okay, so whenever, if you see now, this MnO2 has acted as a oxidizing agent, and this concentrated HCl has acted as a reducing agent. Okay, concentrated HCl has acted as a reducing agent. How would I say that concentrated HCl has acted as a reducing agent? इसने तो ऑक्सीजन दे दिया इसको, लेकिन इसने क्या दिया इसको? इसने तो इसको ऑक्सीजन दे दिया, लेकिन इसने क्या दिया इसको? Oh, that we have to see, because if you see, manganese still has chlorine with it. So I have already taught you about something called, that is oxidation number. But well, so if some of you don't know it, don't need to panic. If you see what is the valency of manganese exhibited over here, if you see, if you write like this, Mn X O is always 2. So and it will become Mn2OX. Okay, So here it is only Mn, so I can write it as MnO x by 2. So here x by 2 is equal to 2, so x will be equal to 4. So here the valency of manganese is 4. If you see here, the valency is 2. If the valency comes down, it is reduction. Okay. So concentrated HCl has reduced the valency of manganese, and when your valency is reduced in a reaction, that means you are getting reduced. So here this is the oxidizing agent and this is the reducing agent. So if it is asked in this reaction that what is the property of concentrated HCl that has been shown in this reaction, then you have to write reducing property. Okay. Second part is balancing this reaction, that is also important. So if you see, this part is already balanced, manganese is already balanced, chlorine is not balanced. How many chlorine is there? 4 chlorines are there, so 4 HCl, and you are left with now 4 hydrogen, so I think it is balanced. Okay. So balancing in this reaction is very easy, but remember what questions that can be asked. Reducing property of concentrated HCl, oxidizing agent is MnO2, okay, and it is a black color compound. Okay, it is a black colored compound which turns to colorless solution. Okay, that is also important. So it can act as a test for MnO2 when we are comparing it with CuO, right? So in case of MnO2, another observation can be asked. First thing is black color changing to colorless solution, and second thing, what observation can be asked? Observation can be asked is chlorine is a greenish. Actually, see, this will form a faint pinkish color. So you can say colorless. Okay, faint pinkish color. Chlorine is greenish yellow. Chlorine is greenish yellow. So greenish yellow color gas will also get evolved. Okay guys, so next reaction we are going to do after we have already done the reaction of MnO2 is KMnO4. Very important compound, right? You will find this compound at various places in chemistry, specifically inorganic chemistry, also in organic chemistry. Organic and inorganic both understands the importance of this KMnO4. It is a very good oxidizing agent when you put it in concentrated acid. Okay? So I am putting concentrated HCl over here. Okay. So what will be the product as per the method we have learned now? This is a very good oxidizing agent. Here this will act as a reducing agent. So this is going to oxidize HCl. HCl को oxidize करना मतलब आपका hydrogen will be taken away. So it will be forming H2O, and if hydrogen goes away, chlorine will remain. So Cl2 will get formed. Okay, and potassium and manganese will form its corresponding chlorides. So KCl and MnCl2. Correct? KCl and MnCl2. Now the thing is, the difficult part of this equation is balancing. We tend to remember the balance numbers, that is around 14 or 16 in this case, and things are not as usual or as normal as we do, right? So in this case I would say you to remember a simple thing, that whenever KMnO4 is in acidic medium, by default or by your first assumption, you put 2 over here and 5 over here. Now 2 तो आपको याद रहेगा, but how do you understand where do you put 5? Always put 5 on the gas evolved. Okay, if there is any gas evolved, put 5. Okay, it will be either 5 or multiples of 5. It will be 2 or multiples of 2, that is for sure. Now first you balance the potassium manganese, the metals, 2, 2. Now you count the number of chlorines. 2 plus 4, 6 plus 10, 16. So 16, and you see it is now becoming very easy because here is 8 oxygen and 16 hydrogen. So 8 H2O. हो गया, ठीक है, very easy. Next is K2Cr2O7 plus HCl. Here also the product will be almost same, H2O plus Cl2. Then salts. What are the salts that are possible? Potassium chloride KCl and chromium chloride CrCl3. In this case, the balance number that you have to remember is, in case of potassium dichromate, as important reagent as we have our KMnO4. Very important. Both of them are very important reagent. Okay, very important, both of them, and you are putting it in concentrated acid, it will act as a oxidizing agent. Okay. In this case, whenever K2Cr2O7 is in any acidic medium, just put this as 3. It will be either 3 or multiples of 3, and don't put any coefficient over here. Second step is balancing the metals as we have done over here. So here it will be 2KCl, 2CrCl3. Count the number of chlorines, 2 plus 6, it will be 8 plus 6, 14, and put 14 over here. Things are as simple, as similar as the other equation, 14H7O, so it will be 7H2O. Okay, so balancing is easy if you go in a systematic way, right? Okay, when you understand the reaction very well, balancing is easy. This was a simple oxidation reduction reaction, nothing else, and we have done this tons of times. Now coming to these equations, what can be asked in ICSE examinations regarding this equation with respect to these equations? With respect to these reactions, what can be asked is, what are the observations? Say this is having a purple color, right? This is having a purple color. Some books it may be have written pink. Pink and purple doesn't have much of a difference. Okay, so let's take purple color only. So purple color turns faint pinkish. This is faint pinkish. If you check the data books, it is faint pinkish. You can also say colorless solution. You can say it like this: the purple color of the solution fades. Okay, a very nice diplomatic answer where the teacher cannot cut any number. The purple color of the solution fades. नहीं तो कौन सा टीचर पिंकिश व्हाइट देख लिया और कौन सा टीचर कौन सा बुक में पूरा कलरलेस सॉल्यूशन देख लिया. ऐसा पॉलिटिकली भी हमको कभी कभी करेक्ट रहना पड़ता है. एनी हाउ, इफ आई राइट पर्पल कलर ऑफ द सॉल्यूशन फेड्स, we always win, and the teachers always, no, they also win, they also win. Okay, and another observation is greenish yellow color gas is evolved. Okay, and now next this one, what is the color of K2Cr2O7? Orange. And what is the color of CrCl3? KCl to white hai, colorless. What is the color of CrCl3? Green. So orange color solution will turn to green, and greenish yellow color will get evolved. Greenish yellow color of a gas that is greenish yellow in color will get evolved. Don't write the name of the gas. Okay, if observation is asked, don't write the name of the gas. Don't write that green color CrCl3 is formed. Just write that orange color of the solution changes to green color solution and a greenish yellow color gas is evolved. Simple, keep it simple. Okay, because observation is what you can see, what you can hear, and what you can understood, I guess. Okay, so and the second thing that can be asked in this reaction is the reaction itself. So both of them are important, observation and reaction. I will give you a homework of two compounds, PbO2 and CaOClCl. Okay, do both of this with concentrated HCl, try to find out what are the products. Okay, now for PbO2, if you see, obviously PbCl2 is going to get formed. PbCl2 is a very important compound, you know. Okay, I have also written PbCl2 over here. It is a very important compound. Whenever PbCl2 gets formed, it is a white precipitate. Okay, see, whenever there is any chlorides, let us take HCl and you put some PbNO3 whole twice in it, you will get PbCl2 plus HNO3. Now it is balanced. Okay, PbCl2 plus HNO3. Now this is a white precipitate which is soluble in hot water, very important. Water. So basically PbNO3 is a reagent for chloride radical, right, for identification of chloride radical. Similarly, there is another reagent for chloride radical, HCl plus AgNO3, which is also very important. It will form AgCl plus HNO3. Okay, AgCl plus HNO3. So if you see AgCl plus HNO3, this is a white precipitate again. Does it solubilize in hot water? No. It is soluble in excess NH4OH. It forms diamine silver salt. A diamine silver complex is getting formed. We have discussed this in our analytical chemistry lecture. Okay. So this is what some important tests of HCl also we have discussed. Okay, very important. HCl or chloride radical. Okay, two important reagents we can use to identify chloride radical: lead nitrate and AgNO3. Okay, very important. Go through this. 20 मिनट में बहुत कुछ सीख लिया हम लोगों ने. इम्पॉर्टेंट है बिकॉज 2-3 मार्क्स कैन कम आउट ऑफ इट एंड 2-3 मार्क्स के लिए आप बुक 20 मिनट तो खर्चा कर ही सकते हो. ठीक है, सो डू इट वेरी फास्ट. ICSE is coming, so we have to do it in a holistical way, in a good way, and we have to score some good marks at the end of the day. Thank you.